This analysis organizes the technologies by their functional domain to clarify their roles and interconnections within your architecture. Classical infrastructure, orchestration, and CI/CD. This section covers the foundational tools that build, deploy, and run your applications. Docker. This is the fundamental unit of deployment. Your backend services written in Spring Boot, Node.js, and potentially parts of your monitoring stack are packaged into Docker images. A Docker file defines the environment for an application, including the Java OpenJDK runtime, application code, and dependencies, creating a portable, self-contained artifact. These images are stored in Google's Artifact Registry. Kubernetes, GKE. This is your container orchestrator. Instead of manually running Docker containers on virtual machines, you declare the desired state in Kubernetes manifests, YAML files. Kubernetes then automates the deployment, scaling, networking, and health management of these containers across your GKE clusters, MQET, MekDev, etc. Terraform. You use this for infrastructure as code ISC. Instead of manually clicking through the GCP console to create a GKE cluster, a VPC, a Cloud SQL database, or a pub subtopic, you define these resources in Terraform configuration files, TF. This allows you to version, reuse, and reliably replicate your entire cloud infrastructure, preventing configuration drift between environments like Dev and UAT. Jenkins. While your stack specifies Bitbucket pipelines, Jenkins serves the same core purpose as a CI/CD automation server. In a typical workflow, a Git push to Bitbucket would trigger a Jenkins or Bitbucket pipelines job. This job would check out the source code, compile the code, and run tests using tools like Gradle and JUnit/Mockito. Perform static code analysis with SonarQube. Build a Docker image. Push the image to your artifact registry. Trigger a deployment in Argo CD. SonarQube. This is your automated code quality and security gate. It's integrated into your CI/CD pipeline, Jenkins/Bitbucket, to analyze your code for bugs, vulnerabilities, code smells, and test coverage. It can be configured to fail the build if the code doesn't meet predefined quality standards, ensuring that poor quality code doesn't get deployed. Fastlane. This tool automates the most tedious parts of mobile app deployment. For your Android and iOS apps, Fastlane handles tasks like building the app, managing code signing, taking screenshots, and uploading the builds and metadata to the Google Play Store and Apple App Store. Telescope observability, monitoring, and logging. This stack is for understanding the health and performance of your systems. Your stack mentions using GCP native tools, but also lists the components for two very common open-source observability stacks: Prometheus, Alert Manager, and Grafana, the PAG stack for metrics. This trio provides in-depth, service-level monitoring that complements the broader infrastructure metrics from GCP Cloud Monitoring. Prometheus, a time series database that actively pulls metrics from your applications. Your Spring Boot services would expose a Prometheus endpoint via the actuator dependency, and your Kubernetes pods would be annotated so Prometheus knows to scrape them. It collects detailed application-specific metrics like request latency, error rates, and JVM memory usage. Alert Manager. This component handles alerts based on rules defined in Prometheus. For example, if Prometheus sees that an API's error rate exceeds 5% for 10 minutes, it sends an alert to Alert Manager, which then deduplicates, groups, and routes the notification to the correct team via Slack, email, or PagerDuty. Grafana, the visualization layer. Grafana queries Prometheus and other data sources like Cloud SQL to build powerful, interactive dashboards. This is where your engineers would go to visualize application performance, correlate events, and troubleshoot issues in real time. Elk Stack, Elasticsearch, Logstash, Kibana, and Filebeat. For logs, while your stack uses GCP Cloud Logging, the Elk Stack is a powerful alternative or supplement for centralized application logging. Filebeat, a lightweight agent that runs alongside your applications, often as a sidecar container in Kubernetes. It tails log files and forwards the log entries to Logstash or Elasticsearch. Logstash, a data processing pipeline. It can ingest logs from various sources via Filebeat, parse them from plain text into a structured JSON format, enrich them with additional data, like GYP information, and then forward them to a destination, which is typically Elasticsearch. Elasticsearch, The same search engine you use for application search is also exceptionally good at storing and indexing massive volumes of log data. You likely have a separate Elasticsearch cluster dedicated to logs to isolate workloads. Kibana, the web UI for your logging data stored in Elasticsearch. It's the Grafana for logs, allowing you to search, filter, and visualize your application logs to quickly diagnose problems. API Gateway, backend services and databases, this is the core of your application logic and data persistence. Kong, your API gateway and Kubernetes ingress controller. All external traffic to your APIs flows through Kong. It's responsible for routing, directing requests like /user-API/v1/users to the correct backend service inside the Kubernetes cluster. Authentication, using a JJWT plugin to validate the JSON web token on every incoming API request, ensuring the user is authenticated before the request ever reaches your service. Rate limiting and security, protecting your backend services from abuse. Nginx, while Kong, which is built on Nginx, handles your API traffic, Nginx itself is a high-performance web server. It might be used inside a Docker container to serve the static assets, HTML, CSS, JS, for your Vue or React front-end applications. Spring Boot/Java Open JDK. This is the workhorse for your core backend APIs, Recipe API, User API. Spring Boot provides a robust, opinionated framework for building high-performance, production-ready microservices in Java. Node.js, its asynchronous, non-blocking I/O model makes it ideal for I/O-intensive tasks. Your Recipe Media service likely uses Node.js to efficiently handle file uploads from users, stream them directly to Google Cloud Storage, GCS, and serve media back to clients without tying up service threads. Python, often used for scripting, data analysis, or machine learning tasks. In your stack, it could be used for data migration scripts, automation within CI/CD pipelines, or potentially for specialized backend services. Redis, a high-speed in-memory key-value store. Though not listed in your primary stack components, it's almost certainly used for caching, storing frequently accessed data from Cloud SQL to reduce database load and dramatically speed up API response times. Session storage, managing user login sessions for your web applications. JJWT, Java JWT. This library is used on the backend within your Spring Boot services to create and sign JSON web tokens when a user authenticates. gRPC, a high-performance RPC, remote procedure call, framework. While your external APIs are likely REST JSON, gRPC is often used for fast and efficient internal service-to-service communication between your microservices, especially in a multilingual environment, e.g., a Java service calling a Go or Python service. Laptop computer front-end and mobile development, this section details the libraries and frameworks used to build your user-facing applications. The vast number of libraries indicates rich, feature-heavy clients. Web, Vue, and React, your stack uses both Vue and React, suggesting either different projects use different frameworks or a potential migration is underway. Core, Vue and React are the foundational frameworks for building your interactive user interfaces. State management, Vuex for older Vue 2 apps or Pinia, the modern standard for Vue 3, and tools like at Tanstack/React Query, for React, are used to manage application state in a centralized, predictable way. UI components, Vuetify for Vue, and at MUI/Material, for React, provide pre-built, high-quality UI components, buttons, forms, data grids to accelerate development. HTTP and Async. Axios is the universal HTTP client for making API calls to your backend. RxJS provides powerful tools for managing asynchronous event streams. Utilities, libraries like Moment and Lodash, are used for common tasks like date manipulation and data transformation. DOM Purify is a crucial security tool used to sanitize HTML and prevent XSS attacks when rendering user-generated content. Android Core Architecture. Dagger is used for dependency injection to manage object lifecycles. RxJava/RxAndroid are heavily used for composing asynchronous and event-based code, making complex operations like concurrent API calls manageable. Networking. Retrofit is a type-safe HTTP client that turns your REST API into a Java interface. It uses OK HTTP as its underlying engine and JSON to automatically serialize/deserialize JSON data to from Java objects. Local storage. GreenDAO is an ORM for SQLite, simplifying database interactions. SQL Cipher is used to encrypt the local SQLite database, securing sensitive user data stored on the device. UI and media. Glide is used for efficiently loading, caching, and displaying images. Exoplayer provides a powerful and customizable solution for video playback. Lottie is used to render high-quality vector animations. Testing. JUnit is the standard for unit testing, and Mockito is used to create mock objects to isolate the code under test. iOS networking. gRPC. Swift is used if you have gRPC-based internal services. SD Web Image is the iOS equivalent of Glide for high-performance image loading and caching. UI. Snapkit provides a simple domain-specific language, DSL, for writing auto-layout constraints in code. FS Calendar is used for calendar views, and Lottie iOS renders Lottie animations. Utilities. Firebase is used for a suite of features including remote config, analytics, and push notifications. SwiftSoup and Canna are used for parsing HTML content within the app. Memo Content Management. WordPress. Your WordPress site serves as the public-facing front-end, tightly integrated with your backend systems. Content creation. Advanced Custom Fields, ACF, Pro and WCK are used to create structured content models beyond standard posts, turning WordPress into a headless-capable CMS. Visual Composer provides a drag-and-drop page-building experience. Integration. ElasticPress is the key integration point. It automatically syncs all your WordPress content into your Elasticsearch cluster, powering the fast, full-text search capabilities of your site. The Amazon S3 and CloudFront plugin is likely used to offload your media library to an object store, similar to GCS, to improve performance and scalability. Performance and I18N. W3 Total Cache is used for caching pages, objects, and database queries to speed up the site. SitePress Multilingual CMS, WPML, handles the internationalization and translation of your content.